In the fifth module, so that is from your textbook, Terenza Chan. Okay, from the textbook. So here we are referring to textbooks. Okay, so you can see here there are two parts from here to from beginning till here. Okay, that is about signals. Okay, for that we'll be referring to Terence Chan book, and for Demon process we'll be referring to Richard textbook. Okay, so there are two topics. One is signals, another one is Demon process. Okay, so first we'll start discussing about signals. So signals are triggered by events and are posted on the process. Okay, to notify it that something has happened and requires some action. Okay, so signals, okay, they are triggered by some events. Okay, so it can be given to a process. Okay, when something wrong happens, and the process can perform some action. Okay, it may execute some functions. Okay, so signals are generated, or it can be generated by a user or by the kernel. So signals, there are different types of signals that can be generated by a process, user, or the Unix kernel. Okay, so here there are a few examples. Okay, these are few examples. So look at here, when the process performs a divide by 0, or it is trying to reference, okay, it is trying to dereference a null pointer. Okay, in that case the process will generate a signal. Okay, so here what happens is, when the process performs a divide by 0, the kernel will send a process a signal to interrupt it. Okay, telling that you are trying to divide by 0. Okay, so an interrupt signal will be sent to the process. Okay, so what happens is, when the process receives the signal, okay, so it might abort its task. Okay, it might abort its task. One more example is, when the user tries to hit the Control C key at the keyboard, or delete button. Okay, so you might have come across in the C programming lab, when something goes wrong. Okay, you maybe click on Control C or Control D key in the keyboard to stop the terminal. Okay, to come out of the terminal. So at that time, what happens is, the kernel will send the process a signal to interrupt it. Okay, so it will sending a interrupt signal. Okay, one more example is, the parent and its child process can send signal to each other. So that is inter-process signal communication. Okay, so that is for process synchronization. Okay, so signals are considered as a soft version, okay, software version of hardware interrupts. Okay, so whenever an interrupt occurs, okay, so any kind of interrupts, maybe divide by 0 or trying to press Control C key. So at that time, a software version, that a signal will be sent. So signals are defined as a integer flag. That means you can give integer values like 1, 2, 3 and all. Integer values can also be given, or it can also be referred with the signal name, or we call it as a signal constant, which is specified within a header file. So this is a header file which is must when you dealing with the signals, that is signal.h header file. Okay. So there are different types of signals. Okay, so in the notes I had specified the different types of signals. You can see here. You can see here, these are different types of signals. Okay, so like this we have different types of signals. Okay, so just to mention few, sig alarm signal. Okay, that is alarm timer timeout. Okay, when the timer expires. Okay, so at that time, these signals can be generated by using alarm API. Okay, similar to open close API, you have alarm API. So that will generate this sig alarm. So this we'll be discussing in detail. Okay, similarly we have sig about. Okay, so that is to abort or terminate the process. Okay, so abort process execution, so which can be given by abort API. So this is a function that we use for generating the signal sig abort. Okay, and we have sig int. Okay, sig int is used for terminal interrupt character. Okay, sig kill, that is used to kill a process. Okay, so you can give few examples. Okay, you can take a few selected signal examples and you can give the description of those example. So next is, so when a signal occurs, okay, when a signal is sent to a process, okay, so process can react to the signals, okay, in three ways. When a process gets a signal, it can react in three ways. The first one is it can accept the signal, okay. So it can accept the default action of the signal. The most signal will terminate the process. So what, when the signal occurs, what will happen? It will terminate the process. It will stop the execution of the process. The next one is what it can react. So when the process gets a signal, it can ignore the signal. Okay, it can discard the signal. Okay. So the third one is when a signal occurs. So when the signal occurs, okay, this is a process. When the signal comes, okay, from the user or from the kernel, it can execute a user-defined function. Okay, this is very important. It will execute, the process will execute a special function which we call it as a signal handler routine. So we can signal handler routine. Okay, so this is a special function, okay, which can be unhooked. The signal is said to be caught when the function is called. So when the process calls this function, we said that, okay, the signal is caught by this function. Okay, similar to your error. Okay, error we have catch, try and all, right. Same way, okay, here this function will catch the signal. If the function finishes execution without terminating the process will continue execution from the point it was interrupted by the signal. So what it can do, after executing this function, it can terminate the process, that is one way, or it can continue the execution. The process can continue the execution. So these are the three ways in which the process can deal with the signals. Okay. So we have different types of signals. Go through those signals. Okay. So based on the marks they ask in the exam, you need to write the answer. Okay. So if they ask you for the more marks, then you need to give some explanation of selected signals. The next one is Unix kernel for signals. Support for signals. Unix kernel support for signals. So this is the structure of the process. Okay. So which I had already showed you in our previous module. Okay, the structure of process. So you can see here, this process will be having different types of tables. It will be having process table, then it will be having a kernel region table, then pre-process region table, okay, U area. And again, there are three types of segments: text segments, data segment, stack segments. Okay. So, so in Unix, okay, each entry in the kernel process table slot as an array of signal flags, one for each defined in the system. Okay, so here, okay, this is our process table. So here process table will be having array of signal flags. So it will be having different signal flags. Okay, one for each signal defined by the system. When the signal is generated by a process, the kernel will set the corresponding signal flag in its process table slot of the recipient process. Okay, when the signal is received, so this will be having, okay, a slot for that signal. Okay, so for example, let us assume that sig L drum occurs. Okay, sig L drum. So this is one of the signal. So, so when this signal occurs, okay, when a signal is generated, this kernel will set the corresponding flag. Okay, it might be having some integer number or it can be a constant which will be stored in the signal table. Okay, next, if the recipient process is asleep, okay, that means it is not ready to take the signal, okay, waiting for child to terminate or executing a pause API. So it is not ready to accept the signal. Then what happens? Kernel will awaken the process by scheduling it. Okay. The kernel, what it will do? It will schedule. Okay, it will make a schedule to run that signal at some point of time. Okay, so it is process is asleep, it is not ready to take the signal. Okay. Then the kernel will assert the array to find out how the process will react to the pending signal. Now this, if the process is not ready to take the signal, then it will become the pending signal. Okay, so this is a pending signal which need to be handled. Okay, so now the kernel will consider the array to find out how the process will react to this pending signal. Now this process is not ready to take the signal. Now how to react to this pending signal? Okay, if the array entry contains a zero value, okay, if the value is a zero, then process will accept the default action of the signal. Okay, if the array entry is 0, okay, here, then the process will accept the default action of the signal. So the signal may be having some default action like terminate the process and all. Okay, or it will, kernel will discard it. Okay, if the value is not 0. If the suppose the value entered, okay, for a particular signal is one value, then the process will ignore the signal. Okay, so remember this value. 0 means accept the signal, 1 means, okay, if the entry is 1 means, okay, 0, it might be having 0 or it may be having 1. So 0 means accept the signal, 1 means ignore the signal. Okay. Finally, if the array entry contains any other value, okay, it is used as a functional pointer for the user defined, okay, signal, okay, handler routine. I said already the process can execute a special function. That function is called as signal handler routine. So what the process will do? The process will execute this signal handler routine. That value, okay, other than any other this value, okay, which will be used as a function pointer. So here, okay, so here you can see, here you have U area and all. Okay, so when the signal is caught, okay, if the process is ready to accept the signal, the kernel will first will check for the signal handler, that is a special function, whether it is ready to execute for the particular signal. Okay, in the recipient U area. Okay, then the call, okay, then call the user signal handling function specified for that particular signal. Okay, so what will be there? This U area will be having the signal, okay, handler. Okay, that signal special function will be there where in the U area. So these are few points. Go through the notes. Okay. So this next concept is, so we'll study about signals. Okay. So all Unix system will support a API. For a signal, we have the APIs. Okay, so this is the API, signal API, which can be used to define per signal handling method. So this API can specify here the signal handler. Okay, So for the particular signal number, okay, or for the particular signal, we can specify the signal handler. So this is the API. So this is a prototype. Okay, we need this header file. Okay, and the API is having the name, okay, signal. Okay, I'll give an example. Here you can write the integer number. Okay, the first parameter is a signal number. So it is a signal identifier. Okay, so which can be denoted with a constant or it can be denoted with a number. Okay, for example, we go for sig int. Okay, this is a signal for interrupt. When an interrupt occurs, okay, any kind of interrupt, maybe divide by 0 or dereferencing a null pointer, any interrupt occurs at that time, are calling a second argument. What is the second argument? It's a handler, that is a function pointer for the user defined signal handler function. Okay. For example, you are defining a function, that is the name of the function, catch. Okay, this is the name of the user defined function. Okay, this function is defined somewhere. Okay, in the code, somewhere you are defining this function catch signal. Okay. So what happens is, whenever signal interrupt occurs, whenever an interrupt occurs, this signal will be generated and this signal will call this user defined function, which we call it as a signal handler. Okay. So this is an example. Okay. So the first parameter is signal identifier and the second parameter is a user defined signal handler function. So we have an example here. So look at this example. So very simple example. Okay. So this is a signal handler. Okay, this is a signal user defined signal handler function. Okay, you can see here this is a name that is defined by the user. You can give any name, and you can see here these are the three types of signals. We are signal APIs. Okay, which are used to define the pre-signal handling methods. So this is sig term, okay, TERM. So this is used for process termination. Okay, whenever the process terminates, we are calling this function sig catch. Okay, is sig for the interrupt. One more. So this is how signal IGN. So sig IGN is for okay. So sig IGN is here. You can see here. Okay. So sig IGN, it is ignoring the signal. So what it is doing? So you can see here. This you have to define. Okay. So when sig interrupt occurs, you are defining. You are calling the signal handler, which is defined here. Okay. What is this? Void int1. So int1 is what? You are seeing here. What is 1? If the value is 1, then you are ignoring the signal. Okay. So that is what declared here. And similarly, whenever the signal SEGV, that is a segmentation fault. Okay, segmentation fault signal. Okay, when the signal segmentation fault occurs, you are calling this signal handler function that is defined. Okay, that is defined here. DEF. Okay, with the value 0, that means calling some default action. You can see here. When the value is 0, you are accepting the signal and you are calling some default action. Okay. So what will be the output of this? Okay, for example, if this signal occurs, okay, process termination, you are calling this function which for which you are passing the signal number. Okay, that is this one. This is your signal number, and you can see here signal number in turn will call this. Okay, whenever this signal number, that is sig term. Okay, signal number is nothing but sig term, terminating signal. Okay, whenever the terminating signal occurs, okay, every time you are calling this user defined function and you are displaying this message with the signal number. Okay, so for example, Okay, so when you execute this, try to execute this program, you will get the output. Okay. So this is a simple example with the 3 signal APIs. This is for termination, process termination. This is for signal, interrupt signal. Okay, and third one is for segmentation fault. So whenever terminating the process, you are calling the user defined function. When the interrupt signal occurs, you are ignoring the signal. When the segmentation fault signal occurs, you are performing some default actions. Okay. So there is one more, that is a sig set. Okay. So this is one more API which has the same prototype. Okay, as similar to that of signal. Okay, but this is used in the version. Okay, this is using the version v.3. Okay, the Unix version v.3 and v.4 supports, okay, this API sig set. Okay, so for a different version of Unix, we have different APIs. In version 3 and version 4, we have this API. Okay, same as that prototype is same, signal identifier and signal handler. Okay, the return type is similar to that of signal. Okay, so that is about signal. Okay, so next comes to signal mask. So each process in Unix has a signal mask. Okay, what is the signal mask? So signal mask will define which signals are blocked when generated to a process. Okay, in the signal mask, it will tell which signals are blocked when generated to a process. Okay. So Unix mask defines which signals can be delivered and which signals are blocked from delivering at a given point. Okay. So when you have a process, okay, when certain signal occurs, okay, this process can make a decision which signal can be handled and, okay, which signal can be delivered or which signal can be blocked using this signal mask. A blocked signal depends on the recipient process. Okay, so it depends on the recipient process. Okay, to unblock it and handle it accordingly. So, once suppose if the signal is blocked, okay, then this process, okay, in our example, this is P1 process, can make a decision about this blocked signal, whether to unblock it or to ignore the signal. Okay, if the signal is specified to be ignored and blocked, okay, it is implementation dependent on whether the signal will be discarded or left pending when it is sent to the process. Okay, for example, kernel will generate a signal. Okay, kernel will generate a signal to the process P1. Now, okay, you are using the signal mask and you are blocking the signal. Okay, now let us give the example as a signal number as signal 1. Okay, this is just an example. You are blocking the signal. Okay, when the signal is blocked, now what the process will do? The process can at some point can unblock the signal. The process have all the rights, okay, to unblock the signal S1, or it can also ignore the signal. Okay, when the process becomes free, it can handle the signal or it can ignore this pending signal. Okay, so this is a prototype, okay, for signal mask, sig pro mask. Okay, here there are 3 parameters: CMD, okay, new mask and old mask. Okay, so first let us discuss about new mask. What is new mask? It is a set of signal to be set or reset in a calling signal mask. Okay, so here we are, okay, telling that the new signals, okay, you're telling that uh, I want to allow the signal S1, okay, just a name, I want to block this signal S2, okay, by, in reality, these are not S1 and S2, this will be having some signal identifiers like sig alarm, sig int and all, okay, but I am just giving the example, okay, that this signal new mask will be having, okay, like a some set of signals, okay, so I will have this set of signal as an example, telling that process can handle S1 signal, okay, and you are blocking the signal S2, okay, so this is your new mask. Then you have CMD, okay, so new mask is nothing but set of signal where you are telling you are want to accept the signal and you want to block this S2 signal, okay. Now CMD, it is, okay, associated, okay, it is connected to this argument new mask, okay. What is this CMD? CMD will be having these values, okay. For CMD you can give these values, okay. So what is this set mask? Sig set mask. It overrides the calling process signal mask with the values specified in the new mask. What is that? Now this process, okay, let us assume the same process will be having certain, okay, predefined, okay, set of signals, okay, some predefined set of signals, okay, the process will be having some signal set which will be having some values, that is it is ready to accept the signal, it is ready to accept C3 signal, it is ready to, okay, it is ready to accept S3 signal, and it is ready to it is not ready to accept this signal S4. So that is, okay, that is a old mask values, okay, old mask values, okay. So these are old values, that is original signal mask values, okay, original values. So it is ready to take S1, S2, S3, and it is not ready to S4. But the new set is what? New set you are telling it is ready to take S1, but it is not ready to take S2. Okay. Now set mask is what? Overriding calling process signal mask with a new value. That means you are deleting old set and you are setting this new set, okay, all the set will be deleted and this new set will be given, okay. If a sig block, that means what? Add the signal specified in the new mask to the calling process signal mask, that means along with this signal mask you are adding even this, okay. Next one is unblock. Sig unblock. That means what? Remove the signal specified in the new mask argument to the calling process signal mask. That means you remove this. Okay. You remove this and go for only this set of masks. Okay. So what is the first one? First one is overriding. So overriding, okay, with the new value. Okay. Second one is adding, okay. Third one is going for this new values. So, okay. What is this? This is your old mask value. So in our example, these are old values. Okay. New mask is what? These are your new set of signal values, and this will tell what to do with the new value, whether to add to the old value or whether to delete the old value and give the new values. Okay. So here we have few more APIs. Okay. So you can see here there are different APIs, okay, which is given with using different functions. And one more thing, okay, what is the return value of this? The return value is 0, okay, on success. Okay, sig mask will give 0 on success. If there is failure, it will return -1. So let us discuss these functions. So sig empty set. Okay, so these are the functions which are used for setting, resetting or querying the presence of signal. If you want to know any detail of the signal, you can go for this set of functions, that is built-in functions. Okay, what this will do when we execute this function, it will clear all the signal flags. It will clear all the signal flags. Okay, it may be having LDROM signal, interrupt signal, terminating signal. It will clear all the signals. Okay, add set. Why add set is used? For adding the set of flags. Okay, so you have to give the signal numbers here. Okay, delete set. So this is used for clearing the flags corresponding to the signal number. Okay, so this will clear all the signals. This will clear signal. This delete set will clear only the signals which you specify with the signal number. Okay, you have to specify the signal number here. Sig and RAM. Okay, uh, sig terminate. Only those signals will be deleted. Okay. Next one is a fill set. So fill set, it will set all the flags in the sig mask. It is used for setting the signal. Okay. And here one more we have sig member. Okay. So it returns one if the flag corresponding to the signal number signal is there in the specified mask. Okay. So in the mask, okay, this is our mask. So this is our new mask. Okay. If this particular signal number, okay, okay, whether it is there in this mask. If it is there, then it will return 1. It is like you're checking whether particular signal is there in the mask. If not, it will return. So 1 if the flag corresponding to the signal number is there in the mask. Okay. 0 if it is not set. Okay, if it is not set, it will give you 0. If there is any error, then it will return you -1. Okay, so there are so many things to remember. So start studying. Okay, don't keep at the end minute. Okay, for any moment, please don't keep. So you will get confused with all APIs. Okay, the third module also we have so many APIs. Even here you have different APIs. Okay, so it is sure that you will get confused. Okay, so don't keep it for the last minute. So this is an example. Okay, so look at this example. So this example, so here you can see we are calling empty set. So we are clearing all the masks. Okay, assume that we have a process P1. Okay, so we are clearing all the signals. Okay, signal set. We are clearing all the signals. Okay, and here, okay, here we have giving. Okay, we are getting the current signal mask. Okay, sig pro. Okay, this is used for getting the current signal mask. Okay, we are getting the current signal mask. If there is any error, it will display the error message. Get the current signal mask. And here you can see we are adding a new signal to the mask. Okay, so we are setting the new signal. Okay, a new set of signal mask we are creating. And what is that set is having? That the set is having, this is your new signal mask, is having the signal sig interrupt. Okay, so this is your new signal mask. Okay. So we are setting the signal interrupt flag. Okay. Now, okay, we are deleting. Okay, we are calling deleting. That is, if this particular signal, if it is there, then you have to delete. Okay, this particular signal is there. Delete this particular signal. That is, clear this particular signal. Okay. Now here, what we do is, okay, sig pro mask. Okay, check whether. Okay, so this is your sig set mask. Okay, so this is your sig set mask. What is that sig set mask? That is your CMD value. Okay, so sig set mask, that means override the calling process with a new value. Okay, So that is a constant that we are using. Okay. If there is any, we have already cleared all the signals. If there is any signal, okay, override with this signal. Okay. So now what's the signal it is having? It is having only, it is capable of handling only one signal. Okay. Now you are checking whether signal hint, okay, that is this, whether particular signal is present in the process signal mask. Okay, you are checking whether that particular signal, that is, this is your mask, this is the one, okay, this is the address, okay, this is, you are pointing to this a particular address. Okay, now you are checking, okay, when the signal, okay, whether this particular signal is present in this mask. Okay, and add it to the mask if it is not there. If it is not there, you have to add that mask. Okay, so now you are adding this particular signal to the signal mask. Okay, if it is not there, and you are checking whether the signal is there. If there is any error, you display this error message. Okay, now what happens now? So this is SIGPRO is used for adding. Okay, it will check whether this signal int is present in the signal mask. If it is there, okay, if it is not there, and add it to the mask. Okay, add it to the mask if it is not there. Okay, and what you are doing here, we are using this API for deleting this particular signal. Okay, now to come to the conclusion, okay, what we are doing in this program is we are adding this signal to the process, okay, mask, and we are deleting this signal. Okay, now the process is having this mask. Okay, that means it is capable of, we are sending the signal, but we are blocking the signal. Okay, the signal is blocked. There is one more, okay, one more API, that is SIG pending. A process can query which signals are pending for via this API. Okay, so process can use this API, okay, to check the pending signals. Okay, so if the process is not ready to accept the signal, it is a pending signal. Okay, at that time this can be used to check the pending signal. Okay, so apart from that, there are few more APIs. Okay, so SIGHOLD. So SIGHOLD API adds a signal number to the calling process mask. Okay, so you can see here, these are APIs which are there in this version of Unix. Okay, for a different version you have to study. Okay, for version 3 and version 4, we are not using these APIs. Okay, these APIs are for the old BST Unix APIs, I mean version. Okay, for version 3 and version 4, we are using this APIs. This is used for adding, this API is used for removing, this is used for setting, and last one, pause, is to remove the named signal from the calling process signal mask and suspend the process until it is interrupted by the signal. So these are the 4 APIs which is there in the Unix version 3 and 4. Okay. Next, moving to the next API, that is the SIG action. Okay, so previous one we studied about signal mask. Okay, so now we will study about signal action. Okay, so SIG action API is called by the process. Okay, so if this is your process. Okay, so this process is calling this API. So the name of the API is SIG action. Okay. Now is called by the process to set the signal handling method for each signal it wants to deal with. Okay, so this is meant for, okay, action. Okay, for specifying the action. For each signal number, you are specifying the action. Okay, action is nothing but which is given in terms of signal handling methods or user defined functions. Okay, so here we are having old action and this is our new action. So there are three parameters. Okay, so this is a prototype. So first parameter, it is the signal number. Okay. Second parameter, it's a structure. You can see here, it's a structure. The name of the structure is a sig action, which is specified here. So this is our structure, sig action. Okay, which has three members. Okay, these are the three members. The first one is specifying the signal handler. Okay, handler field which can be set to, okay, this can also have these values. So this is for ignoring the signal, and this is for uh, performing certain uh, actions. Okay, or you can also specify here user defined function. Okay, so this one can be set to these three values. So it can have a built-in value sig ignore for ignoring the signal, for performing some default action, and this is to perform the user defined function when this particular signal occurs. Okay, next one is SA mask and flag. SA mask field is an additional signal that process wishes to block. Okay, here you can specify some additional signal which this particular process wants to block when it is handling the particular signal. Okay, and here it is a SA flag. Okay, SA flag is nothing but okay. So here we are having SA flag. Okay, SA flag is nothing but these flags can be used to specify uh, the style of the Unix handling methods. Okay. It is given in the it is available. Okay, different values are available, like different flags are available, like sig, SA, reset handle. Okay, reset handle. So these are built-in flags. Okay, mainly these flags are used for, okay, restart. There are different flags. Okay, so if the signal number is called, SA handler is set to default signal. Okay, so we not worry much about this. Okay, signal flags. So this tells, flags will tell how to handle the signal handlers. Okay, so you can write this prototype when they ask in the exam. Explain the structure. Okay, explain this different members. Okay, and give some example. You can give this example for the signal flags. Okay, so this will affect. So this will have some effect on the signal handling, signal numbers. Okay, so we have an example here. Here. So this is our signal handling function. Okay, user defined signal handling function. Okay, which is used for handling a particular signal specified in the signal number. Okay, signal handling function. Now here this is our signal action. Okay, and here we have different structures and all. You can see here this is action, this is for old action. Okay. Now here let us go to the main function. Okay, we have defined different members. Okay, so here we need here sig mask. Okay, which is of type sig set. Okay, these are all we have to remember. Okay, so which is of type sig set, and here we are having for the structure signal action, we are defining two variables. One is action, another one is old action, which you need for function API sig action. Okay, first one is you empty all the signal mask. Let us assume that you have a process P1. Okay, and this is your signal mask. You empty all the signal mask values, and what signal you are adding? You are adding this signal sig term. Okay, you are trying to add the signal. Okay, So here you can see here it is or. Okay. If you are able to add, okay, if this is true, it will go for the next one. Okay, so you know about OR conditions, right? OR condition, it is not like your AND condition. Okay, so if one condition is first, it will check for the condition, and if both the condition is true, it will return true. Okay, so now you are adding what signal? You are adding the signal sig term. Okay, so you are adding the signal term. Okay, for the mask, you are adding this signal. Okay, this is the name of the signal. And here we are calling sig pro mask. What is the sig pro mask? What it will do? Okay, it will add that signal, particular signal to the mask. Okay, and if there is any error, it will display the error message. Okay. Now here what we do is, so here so signal mask, okay, signal process signal mask is set to term, okay, signal, and the process then defines the signal handler. Okay, you can see here it will also add, okay, it will also add, okay, you can see it will also define for the particular. Okay, it will also add this one more signal. Okay, you can see it will add one more signal, that is sig SCGV. Okay, that is a segmentation signal. Okay, and whenever the particular signal occurs, okay, you are calling the action. What is the action here? What is the handler name? That is the name of the function. What is the name of the function? It is call me. Okay, so process then defines the signal handler. Okay, for the sig int signal. What is the signal? Sig int signal. Okay, you are defining the signal handler and also specify that, okay, sig, sig, uh, sig segment signal is to be blocked when the process is handling the sig int signal. Okay, so here whenever sig int signal occurs, okay, so that is action. Okay, when signal sig int occurs, we are calling the action. Where the action is defined, it is defined here. Okay, what is the action? Action dot sa handler is equal to call me. So what it will do, whenever this sig int occurs, it will call this function, okay, which will define this number. So this defined number, what it will display? Catch signal. So this is a number you are passing. So this is the sig number, sig int. Okay, so that will be displayed. Okay, if there is an error, it will display the message. Only thing, okay, you need not write much in the exam. Okay, just you have to write this. Okay, write this line, add the signal. Okay, and you have to write this action. Okay, and you have to write the flag. Okay, because you have all these things here. See here, SA mask, okay, SA handler, and SA flag. All these are there in the structure SA action. Okay, you can see here you have defined the structure SA action. Okay, the members are action and old action. Okay, for the action you have defined the handler, that is the user defined function call me, and for the flag you have defined with the value 0 and action dot SA mask. Okay, action dot SA mark, what you are doing? Okay, these two are signals you are specifying. Okay, okay. So for these two are the signals you are adding. One is sig term, okay, and sig SEGV. These are the two signals you are adding. And this line, what it will tell, whenever the signal interrupt signal occurs, you have to call this action. So what is the action? It is this function. Okay. So just to round up, okay, to tell in brief, okay, you are defining a process here, and for the process, okay, you are adding two signals, okay, add set and add set. You can see here these functions are used for adding the signals, okay, to the mask. Okay, these two signals are added, and this line what it will do, this line will check for the signal int. Okay, if this particular int signal occurs, it will perform the action. What is the action? Action is defined by the handler to call this user defined function, which is defined here. Okay, so this is a signal number. Okay, so this is a signal number you are telling. So that is sig int, which will display this message. Okay, whenever signal interrupt occurs, your output will be catch signal colon, okay, colon sig int. That is only for one signal. Okay, only for this signal. Only when this signal occurs, this user defined function will be called. Okay, this is not for these two signals. We are adding only these two signals to the mask. Okay, but you are not defining any action for this two signal. But only for this signal you are defining the action. Okay. So this is about signals. Next, moving to the next signal, sig child signal and wait PID signal. Okay. So when the process terminates or stops, the kernel will generate the signal. Okay, I'll call it as sig child signal. Okay, to its parent process. Okay, so let us assume that there are two processes. I'll give the name as parent and child. Okay, when the child process terminates or it will stop, okay, the kernel will generate this signal. Okay, so you have to remember. So depending upon how the parent set up the signal handling function, okay, different events may occur. Okay, so depending upon how the parent sets up the signal handling to the signal, this particular signal, different events occur. So what are the different events? There are three types of events. Okay, what the parent can do, okay, when this particular signal occurs, when the kernel generates this signal, parent can accept the default action. Okay, so when this signal will be having certain default action. Okay, so parent can perform that default action. That means it can, for example, this signal does not terminate the parent process. Okay, it affects only the parent process if it arrives at the same time the parent is suspended by the wait PID system call. So if you remember, we discussed about this system call, wait PID system call. The wait PID system call is used to get the information about the terminated signal. Okay, so first action is default action. Okay. Next one, what the parent can do? First one is perform default action. Okay. Parent can perform default action when it receives a signal. Second one is what? It can ignore the signal. Parent can, what it can do? It can ignore this particular signal. Okay, and this signal can be discarded by the parent, okay, without even executing this. You don't want anything, you don't want any information about the child. Okay, simply what the parent will do, I am not interested with this child process details. I don't want any signal. It will ignore that signal. Okay. Next one, what it can do, it can catch the signal. It can, what it will do, it will accept the signal, and what it will do, it will call some user defined function that we call it as signal handler function. For example, in our example, it was this, correct? So this is user defined function which is called for the particular signal sig int. Okay. Same way, when this particular signal occurs, you can call some function. Okay. User defined function which we call it as signal handler function, which can be called, okay, whenever the child process terminates. Okay, so these are the 3 actions. So this is all for today. So if you have any doubts, please ask. So don't keep at the end minute. Okay. Practice all the APIs, write and study.